about portfolio diversification and how that has an impact on corporate finance. Just like people who manage a portfolio of stocks, who want to add assets to the portfolio that give them the greatest return for the least amount of risk, as a corporate financial manager, you want to do the same thing. You want to put assets on the balance sheet that are going to give you the greatest return for the least amount of risk. At the end of the day, if you do that now, you're going to maximize the value of the firm, maximize the wealth of the shareholder, going to maximize the price of the stock in the market. So that's an important thing to do. And in that vein now, there are a couple of statistics here that you need to understand and have an understanding for. And one is the covariance statistic, and the other is the correlation statistic. And we're going to talk about both of those right now. Now, covariance and correlation, these are statistics that look at the interrelationship of two assets. So you might already have a portfolio, you already have assets on your balance sheet, and you're thinking about adding a new asset. And the question is, how would that new asset impact the risk and the return of the portfolio that you have? Now, the correlation, or the covariance term rather, the covariance term is defined as the mean of the product of the deviations. So you'll remember deviations from an earlier video. It's the observation minus the mean. So we've got the observation minus the mean for the security and the observation minus the mean for the market. The product of the deviations mean we're going to multiply all of them, all of the paired deviations together. We're going to sum all of that stuff and divide by n minus 1. So indeed, you multiply the deviations together for each period, sum those deviations, and you divide by n minus 1. Okay, in our statistics example, that would be 6 minus 1, or 5. The covariance term. Now, covariance can take on any value between negative infinity and positive infinity. As I said before, this is a wide range here, but that's what covariance does. As you look at how you calculate covariance, note that you can have positive deviations and negative deviations for these two assets at each point in time. And indeed, if these were both positive, then a positive times a positive would be a positive number. That means both these assets are on the upside of their means at the same time, both generating positive deviations. On the other hand, you could have both these assets being on the downside of their mean. They're both generating negative deviations. A negative times a negative is also a positive. If you have a large positive covariance, what that means now is that those two assets' returns tend to be on the same side of their mean at the same time. They could both be on the upside of their mean at the same time, or they could be on the downside of their mean at the same time. Either way, positive times a positive is positive, a negative times a negative is also a positive. And so you have large positive covariance. That means the two sets of numbers tend to be on the same side of their means at the same time. Now, if you had one on the upside of its mean, generating positive deviations, and the other one generating negative deviations on the downside of its mean, a positive times a negative would be a negative number. If you have large negative covariance, what that means is that the two sets of numbers tend to be on the opposite sides of their means at the same time. In a diversification exercise, when you're searching for other assets, that's what you would like. You'd like to see large negative covariance. That is, one's on the positive side of its mean, it's going to generate positive deviations, while at the same time, the other is generating negative deviations. It's on the downside of its mean. That's negative covariance. Now, this business of negative infinity to positive infinity, that's a problem. You never know when you're looking at a covariance term whether it's a high positive covariance or a low negative covariance or a high negative covariance. You just have no idea because it takes on such a wide range of values, or it could. To get around that now, we calculate what's known as a normalized covariance term. And a normalized covariance term is indeed the correlation statistic, the small r. And that can only be done now between two sets of numbers at a time. And to calculate the correlation coefficient, you take the covariance between the stock and the market, and you divide it by the product of the standard deviations. That is, you're going to multiply the standard deviations together and divide that into the covariance term. And when you do that, you find out that a correlation coefficient can only take on values between +1 and -1. A normalized statistic, such as correlation coefficient, means that they have boundaries. It can't go outside of the boundaries. You're putting you're able to see some meaning to the number that you calculate. So if you calculated a correlation coefficient to be a +0.98, that's a very high positive correlation coefficient simply because why? It can only be 1. That's the highest it could possibly be. And if you calculated a -0.15 correlation coefficient, that's a pretty low negative correlation. It's not near a -1. On the other hand, if you had a -0.92, that's a very high negative correlation. And again, gives you an idea of how strong the interrelationship is between the two assets. In a diversification sense now, you'd like to find assets that have large negative covariance and very high negative correlation. That's what you'd like. Those two assets combined now will give you more return and less risk. And that's what you're looking for in diversification. And that's what I want you to understand and get from these two statistics here that you would commonly look at if you were looking for diversification candidates for your portfolio, or if you're looking for something to diversify the asset base of your corporation.